Hello students, welcome to the channel The Royal Chemistry or About Chemistry. இன்னைக்கு நம்ம வீடியோல பார்க்க போறது Van Arkel method. இது class 12 chemistry metallurgy unit 1 ல இருந்து பார்க்க போறோம். So, it's a vapor phase refining process. So, refining process பத்தின எல்லா refining process பத்தின videos நான் இதுக்கு முன்னாடி நிறைய போட்டிருக்கேன். நீங்க அதோட லிங்க் நான் descriptionல கொடுக்கிறேன். நீங்க போய் check out பண்ணிக்கோங்க. So, இன்னைக்கு நம்ம பார்க்க போறது இந்த last refining process vapor phase method. அதுல ஒரு process தான் Van Arkel method. Let me explain about this refining process now. Vapor phase method. So this vapor phase method carry out in two different steps. Let's see about that. What is the principle behind this process first? Let me explain. If you impure metal is converted into a volatile compound and the volatile compound should be decomposed to get the pure metal. So this process is carried out in two steps. One is what I told you, that impure metal should be converted into a volatile compound by adding suitable reagent. And the second step is that volatile compound has to be decomposed and then only we will get the pure metal. This Van Arkel process was developed in the year 1925. Here the titanium of high purity was made in small quantities by the scientists. Now let's see about that Van Arkel process. The crystal process was developed by two of them. One is Anton Edward Van Arkel and the another person is Jan Hendrik Deboer. Okay, this Van Arkel process was the first industrial process for the commercial production of a pure ductile metallic zirconium. So metallic zirconium refine பண்றதுக்கு first யூஸ் பண்ண ஒரு industrial process இந்த Van Arkel process. Zirconium metal பாருங்க அது எப்படி இருக்குன்னா so it is one of the type of zirconium metal as formula is ZR. Okay, and with the it is given here, you can notice down. So video skip பண்ணாம முழுசா பாருங்க, subscribe பண்ணாதவங்க பண்ணுங்க. So this process where we are using this Van Arkel process, the Van Arkel process used for the production of small quantities, but the purity is very ultra. So ultra pure of titanium and zirconium, both you can get in a high purity by using this Van Arkel process. It's a refining process. Now let me explain about the principle of the Van Arkel method. So what is the principle behind this Van Arkel method? Let me tell you. The picture what we are seeing here is titanium and the other one is zirconium. ZR is zirconium. Okay, now let's see about the principles of the Van Arkel method. What is the principle behind this? The method is based on thermal decomposition of metal component. What do you mean by this thermal decomposition? Let me explain that first. What is that thermal decomposition? So the process of decomposition of a compound into different substance due to the supply of heat. ஒரு காம்பவுண்டை டிஃப்ரெண்ட் சப்ஸ்டன்ஸாக பிரேக் பண்ணுறதுக்கு நம்ம ஹீட்டை யூஸ் பண்ணுறது தான் என்னது thermal decomposition. Process of decomposition of a compound into different substances due to the supply of heat is called thermal decomposition. So using this Van Arkel process, the titanium metal is purified and this is the picture of titanium metal. Now let's see about which types of metals we can refine by using the Van Arkel method. Let's see about that. Okay. So which type of metal? Already I told you that the types of metals to you. The types of metals are zirconium and titanium. Yes, of course. So Van Arkel method is used for refining zirconium and titanium. In this method, which is the impurity present here? So the impurity present in this process is oxygen and nitrogen that are removed by heating the metal in an evacuated vessel. Do you know what is that evacuated vessel? Let me tell you at last. Okay. So impurities are removed by heating in an evacuated vessel in the presence of iodine. Evacuated vessel அப்படிங்கிறது என்ன அப்படின்னா vacuum vessel. Okay, vacuum conditions inside in. That is, vacuum is empty space. Okay, clear for that? So the metal iodide volatilizes and it decomposed on the tungsten filament and heated to about 1800 Kelvin for the decomposition. High temperature we have to give now. That is the thing. Okay. Now, what is the process behind this Van Arkel method? What is the process behind this Van Arkel method? This carry out in 2 steps. So one, we have to form the volatile compound and then on decomposition we'll get the pure metal. Okay, step 1 is we are taking impure titanium metal. So the impure titanium metal is treated with a reagent here. Which is the reagent we are using here? Iodine is the reagent we are using here for the reaction to carry out. So this iodine reacts with the impure titanium metal, and at the temperature we have to maintain of about 550 Kelvin you have to maintain. That is, we have to heat in an evacuated vessel. Evacuated vessel, already I told you that it is a vacuum vessel and a vacuum condition, the vessel which has vacuum condition inside it, and vacuum is an empty space. Okay. Now we are getting titanium tetraiodide, that is a volatile compound. Titanium tetraiodide. That is a volatile compound. Where the impurities are left behind, they do not react with the iodine. Okay, so it is very easy to remove the impurities by the first step itself. The second step is, here that complex compound is going to react with the, okay, this is the equation given for you for that first step, and both I have given, but first step is titanium with iodine gives at 523 Kelvin we are getting titanium tetraiodide. Now the step 2, what is the step 2? Step 2 is the conversion of the complex compound into an pure metal by decomposition. Yes. So here titanium tetraiodide, the vapor of the titanium tetra, the volatile titanium iodide, tetraiodide vapor is passed over a tungsten filament. So it should be passed over a tungsten filament around the temperature of about 1800 Kelvin we have to maintain. So we will get pure titanium, and iodine is, we can reuse that iodine. Okay, got it? These are the 2 steps. Here this is the reaction carried out here. Titanium plus iodine gives titanium tetraiodide, and titanium tetraiodide on heating at 1800 Kelvin we will get titanium back, and iodine can be reused. Same Van Arkel method is used for getting pure zirconium from the impure zirconium metal. It should be treated with iodine. We will get zirconium tetraiodide as a volatile compound. Then this on decomposition will get pure zirconium. So what is the role of iodine in the Van Arkel method? It's very important question now. Why we are adding purposely iodine here? The iodine plays 2 roles here. One is, the role of iodine in the process is capable of forming volatile salt. So first it forms volatile salt with titanium as well as zirconium, and there is if you take titanium, it is titanium tetraiodide with iodine. Second thing is, in this process the iodine is used to remove the impurities present in the crude titanium. That is impurities does not react with the iodine. You know it now. That's why. So these are the 2 important roles of iodine. So now here we are going to see about the uses of the zirconium and titanium. So here the zirconium and titanium are used in dental implants. This is about zirconium and titanium. So this is the Van Arkel method, is important method for getting high purity of the zirconium and titanium. Hope you will understand this video about vapor phase refining, that is Van Arkel method to get high purity metals like titanium and zirconium. My next video is about lesson 4, D block elements, that is named as inner as well as transition elements, and inner transition elements will be present there. So D block elements. Thank you for watching. Do subscribe, share, comment, and share the video with your friends. Be happy always.